Portfolio risk and return. The framework for portfolio risk is as follows. First of all, we need to know what's included in the portfolio. And in this case, we have two stocks, X and Y. Then we need to know how exposed the portfolio is to each of these stocks. So that would be the weight assigned for each stock. And then we need to see how volatile each stock is. And that's captured by the standard deviation of each individual stock. So if you look at it, for each stock, we need to know just the weight and the risk. So then what I'm going to say, because we have a two-stock portfolio here, I'm just going to combine these two together. I'm going to say, okay, let X represent the exposure to X and the volatility of X, and Y will represent the exposure to Y and the volatility for Y. So now, when I'm asked to calculate the standard deviation of the portfolio, all I have is X and Y. Those are the two stocks. However, if you recall from a previous module, when we're quantifying dispersion, we always square these dispersions so that the positives and the negatives don't cancel each other out. So by squaring, even the negative dispersions become positive. So that's exactly what I did in step 2. I squared both sides. That's it. And then in step 3, I'm just going to expand and multiply. So we have x squared plus y squared plus 2xy. And now what I'm going to do is I'm going to bring in or substitute what the x and y stand for. So the x was wx times standard deviation of x squared. And similarly for y, it's the weight in y times the standard deviation of y squared. And then 2xy, what I've done here is, so I'm definitely combining these two together because that's x times y. But what I did is I grouped the weights together, so wx, wy, and the standard deviations together. So all this is elementary algebra. However, when you apply this in the context of portfolio management, we need to make a manual adjustment. And here's a manual adjustment. When you're looking at the risk of the two securities, you have to indicate whether these securities are moving in the same direction or opposite direction, because that will have a huge impact on the portfolio's volatility. For example, if they're moving in the same direction, and that's what volatility captures, right? It's dispersion. So if these stocks are always moving in the same direction, so if one goes down, then the other one goes down, and that is going to make the portfolio more volatile. On the other hand, if the correlation is low, in other words, they don't always go in the same direction, and in fact, it's possible for a correlation to be negative, indicating that they move in opposite directions, then if one goes down, the other one goes up, and therefore that'll make the portfolio less risky. So ladies and gentlemen, here is your framework for portfolio volatility. And where the curriculum just says, here it is, we started with something as simple as that. And I guess what I'm trying to preach here is you shouldn't memorize this. Instead, you should use the ground-up approach that I just illustrated there. This will ensure that we don't make little clerical mistakes. Now, let's talk a little bit more about correlation. Recall that correlation is just the covariance of x and y divided by the standard deviation of each of the individual stocks in this case. So therefore, we can rearrange this framework to as follows. So we're just going to set it as a function of covariance. And that would simply just equal to correlation times the standard deviation of each of the components. And the reason I'm showing you this is because here's our original framework for portfolio variance, right? But since these three terms together is actually covariance, what they might do on the exam is they may group these three into one and just use covariance instead. So there's two ways that the portfolio variance framework may be expressed. It just depends on whether they give you these set of variables or these set of variables, but of course they are equal. So now let's do an example. So for this particular portfolio, once again, we have stock X and Y. Now the portfolio has 70% invested in X, what that means is if you have a total of $100 in this portfolio, $70 is invested in X and $30 is invested in Y. And the expected return for X is 8, whereas the return for Y is 20, and the standard deviation is 14 and 35 for both stocks respectively. But you have to remember again, ladies and gentlemen, when it comes to portfolio management, we need to know if these volatilities are moving in the same direction or opposite direction. And in this case, the author gave us that data in terms of covariance. So whether they give it to us in the form of covariance or standard deviation, they're really capturing the same thing, the degree of co-movement between X and Y. Okay. Now, one tip I have for you here is when you're doing algebra, we really should enter percentages as decimal. So the author gave us the information in the form of percent. Let's see if we can convert that to decimal. So here it is. Part 1, what is the expected return of the portfolio? Well, the portfolio is really just a basket that contains 2 stocks. We just need to know the weight in each and the return of each stock. So 70% invested in stock X, 8% return, and stock Y, 30% exposure with 20% return. So therefore, the portfolio return would be 0.116. And then since we have the final answer, then we can convert it back to percent. So that works out to 11.6%. So then the analyst wants to know, well, what's the risk of the portfolio? So remember, this is just the average. That's just the expected value. So if you're looking at, let's say, a 10-year horizon, that's just the average over the 10 years. Yeah, but what's going to happen during the 10 years? In other words, how volatile or how dispersed will the portfolio be around that average? And that's where standard deviation or variance comes in. So I showed you how to derive the framework for variance using the ground-up approach. And a really neat way to break down portfolio variance is as follows. Where's portfolio volatility coming from? It's coming from your exposure to stock X, from your exposure to stock Y, but it's also affected by the degree of co-movement between X and Y. So we just plug in the numbers there, right? And again, you really should enter, when you're doing algebra, which is what we're doing here, you should enter percentages as decimals, and that's exactly what we've done. So it really just is a matter of plugging in the values. And you could see that even though covariance was given to us as negative 0.6, in decimal form it's negative 0.006. And I show you the interim values, and then finally we get this value for variance. But then after we've calculated variance, we reverse the square, right? So remember, we square first to avoid the positive and negative dispersions canceling each other out. But then when you have a value for that dispersion, you reverse the square by taking the square root of that. And then you get 0.135, which works out to 13.5%. So ladies and gentlemen, do you see how return and risk always go hand in hand? You can't just look at average return. You can't just say, oh, over the long term, you'll be fine. That's not how it works. You have to tell the client how volatile their portfolio is going to be in the process. Like, I know the average is over the long term is 11.6, but how volatile will the portfolio be year over year? So that's why these two numbers go hand in hand, i.e. return and risk. Now, if they ask us to calculate the correlation between X and Y, here's the framework for correlation. So it's just a matter of plugging in these values. Again, whenever I'm doing algebra, I like to enter percentages as decimals. So therefore, the correlation would be negative 0.1224. And notice, ladies and gentlemen, here's the thing. You know standard deviation can never be negative. There's no such thing as negative volatility. So therefore, the correlation and covariance will always share the same algebraic sign. So since the correlation was negative, since covariance was negative, correlation will also be negative.